Hello, everyone. Welcome to Your Health in Your Hands. I'm Dr. David Ajibade with the Brain and Body Foundation. Uh, Remember, we've been, amongst other things, provide healthcare solutions to medically fragile children, children with genetic disorders, children with brain disorders, and of course, sickle cell disease. Every Friday, just as a reminder, we have a free clinic from 10 a.m. to 2 p.m. every single Friday, where you can go there and you can collect your medications and nutrients that help to helping your child's hopeful recovery. So just you can go to our website and find out about that. Now, we are still in the COVID-19 season, and there are, as you remember, we had a talk by Dr. Shrivastava, who talked about what's called stem cells and how stem cells can help in the process of recovery from COVID-19. And as you know, we are always focused on the most basic, the most fundamental solutions. So while that is important, and if you can access that, that would be great. But the truth is, we don't always have access to those kind of solutions in Nigeria and other parts of Africa. What we do have access to, which we'll be talking about in the subsequent few minutes and probably an hour, are things like vitamin C and how it can be used in certain conditions. Our guest today, and I'm really, really honored and privileged to have him on, is Dr. Fowler, and he'll be talking about the relationship between sepsis and pulmonary disorders. And of course, we'll be talking about how that can be applied in COVID-19. So without much further ado, I want to say hello, Dr. Fowler. Welcome to the show.
And thank you very much for the invitation. My name is Alpha Fowler. I'm a professor of medicine at Virginia Commonwealth University in Richmond, Virginia. And my colleagues and I have been studying vitamin C as a therapy for sepsis and acute lung injury now for approximately 15 years. And we have done some major national trials using vitamin C in patients with acute lung injury that has occurred from sepsis and the viral illness that's producing respiratory failure around the world, and that unfortunately is taking too many lives from us, is very similar to a problem that we've confronted for 100 years in the intensive care unit called acute respiratory distress syndrome. We abbreviate that as ARDS, and we've tried for years to come up with a solution and a therapy to be able to save lives. And not until we did this recent phase 2 multi-center trial using very high doses of vitamin C were we able to show that vitamin C can save lives. This is in patients with bacterial and viral sepsis who have acute lung injury, and it may be very relevant to treatment of COVID pneumonia patients who act very, very similar to patients with bacterial generated ARDS.
But so, Doc, if I may jump in here, you're talking about sepsis and how it affects the lung. But with COVID-19, we're talking about an initial lung disorder which becomes systemic and probably septic. So it's almost like the reverse of what you're talking about now. How do we reconcile the two?
Well, viremia, which is the SARS-CoV-2 virus, produces a syndrome very similar to bacterial sepsis. And there are many disease processes that will produce acute lung injury, including viremia. And so in situations such as COVID-19, whether it's primary infection with the virus leading to lung injury, or whether it's the virus leading to a secondary bacterial infection and sepsis leading to lung injury, vitamin C would make sense in all of those instances.
And you're going to explain to us how exactly that can work, because I remember I watched some of your videos online, and I posted on my platform, our old school association, medical school association platform, and they couldn't believe it. They're like, that's ridiculous. There's no way vitamin C, something as simple as vitamin C, can actually have any effect on sepsis or ARDS.
Well, let me say this. Vitamin C, when you give it in extremely high concentrations intravenously, vitamin C becomes an interventional drug. It is potently anti-inflammatory. It calms the inflammatory system in many different respects. So what you have here are two X-rays, and this happens to be an X-ray of an individual with bacterial sepsis-induced acute lung injury. But really, it looks identical to the lung injury in patients with COVID-induced respiratory failure. The important thing about bacterial sepsis is there have been over 5 decades of clinical and basic research that have looked for a solution to saving lives. And despite 50 years of work, effective drug therapy has been elusive until citrus ALI. In the circulation in patients who are septic, and this applies also for COVID sepsis, and we have shown this in COVID sepsis as well, is that in the circulation, low plasma levels of vitamin C, which occur during acute illness, is a constant feature in patients with sepsis. Low levels also of vitamin C give a high incidence of multiple organ failure. And then finally, low levels correlate directly with poor outcome and poor survival. And if you look at the references at the bottom, this dates back all the way to 1996.
Are you going to explain why these low levels, how they relate to all these different things you just pointed out?
Yes, let's go through this.
Okay.
The question we asked, could vitamin C repletion alter the outcome of patients with sepsis-induced acute lung injury or ARDS? So when vitamin C is infused intravenously into the circulation, it immediately binds to a receptor population that's on all vascular endothelium. And the receptor itself literally vacuums vitamin C out of the circulation and transports it across endothelium. It then binds to another receptor on the alveolar lining cells called alveolar epithelium and pumps it directly into the alveolar space. So the important feature of this is vitamin C is a micronutrient. It's not a protein. It's a micronutrient that when it is infused into the bloodstream, it immediately gets transported into where it's needed in the alveolar space.
And the alveoli are the air sacs in the lungs.
Exactly. And so what you have here is a single alveolus and a capillary running by the alveolus. And what we have known for many years now is that the pink cells, which are blood neutrophils become trapped in the capillaries around the alveoli and very rapidly are transported into the lung where they create damage. And what happens is this barrier between air and blood gets broken and blood and plasma floods into the airspace here, showing you basically the yellow is plasma flooding into the airspace and basically drowning the patient. When we infuse vitamin C, the idea is to get the vitamin C into the alveolar space where all these cells are to basically calm down the inflammatory response. In preliminary studies that we conducted, we showed, we developed a mouse model of lung injury due to bacterial sepsis. And we showed that vitamin C could reduce the amount of inflammatory proteins that are in the lung and in the bloodstream called cytokines and chemokines. We also showed, like I showed you right here, that in this model, vitamin C would reduce this neutrophil infiltration into the lung. Vitamin C would also reduce what is called neutrophil extracellular trap formation. Because when neutrophils make their way into the alveolus, what you see here is the neutrophil exploding, and it disgorges its DNA with all of the enzyme systems which are activated, and it wreaks havoc in the alveolar space. And we showed very clearly that vitamin C would reduce neutrophil extracellular trap formation. It's abbreviated NET or NET formation. The other thing too is that this is very important. Critical care doctors who are struggling with patients with lungs full of fluid are just ventilating them for days or sometimes weeks. And we have to have a way of clearing that fluid out of the airspace. And we showed in our animal model that vitamin C would dramatically clear alveolar fluid from the alveolar space where all the air is. And we also showed that vitamin C would enhance the barrier function between air and blood in the lung. We then went on.
If I may just jump in here. If I may?
Yes.
So the one that makes the most sense to the, let's say the newbie, the person who has never really studied this, is the barrier function, because we know vitamin C is very important in collagen formation and in the integrity of walls and in endothelial cells and everything like that. But what you're showing me here, or what we're seeing here, is that all these four things that it does, these are all things that are caused by the body, the human body's response. I don't see anything about sepsis or the virus. So basically you're saying that all this damage and problems that are in the lungs are because of what we are doing to ourselves?
Perfect description, because you can look at sepsis like throwing gasoline on a fire. It ignites the body's immune system, and the body's immune system spirals out of control. And what vitamin C is doing is interrupting that spiral.
Interesting. Please proceed.
So we then moved to a small trial of patients with sepsis in our intensive care unit here at Virginia Commonwealth University. And what we showed was that if we give high doses of vitamin C every 6 hours for 96 hours, that we could reduce organ failure. And what you see, this abbreviation, SOFA, stands for Sequential Organ Failure Assessment Score.
Right.
And we also decreased some proteins indicating inflammation.
Right.
We then took it to a phase 2 trial, multi-center, 7 enrollment sites, so-called phase 2A multi-center trial. And this was a proof of concept trial, randomized controlled trial that was double blind. So nobody knew what the patient was receiving. We were looking for efficacy of physiological variables as well as biochemical endpoints, not clinical endpoints. We were working with well-characterized patients with sepsis. We were working.
What does well-characterized patients mean?
Well-characterized patients with sepsis and acute lung injury.
What does that mean?
That's what the NIH wanted. The NIH gave this program out called the UM1, and they were looking for treatment on well-characterized subjects, bacterial sepsis, acute lung injury. They were looking for a novel immunomodulating therapy for acute lung injury and a common drug with low toxicity.
Vitamin C does that. Doc, just a quick minute. We have to take a short break. I almost forgot. We should have a short break at this point. So
Okay.
folks, don't go away. We will be right back. This fascinating study. Welcome back. We are continuing our study with Dr. Fowler, who is a professor from the Virginia Commonwealth University, talking about his study with vitamin C and sepsis and its effect on the lungs. Please go ahead, Doc.
Okay. So the National Heart, Lung, and Blood Institute in the U.S. put out this request for proposals. We submitted a proposal and got funded for $3.2 million to do a 7-center trial.
Wow.
And this multi-center trial was conducted at Virginia Commonwealth University, at the Cleveland Clinic in Cleveland, Ohio, as well as a large medical center in Cleveland called the Fairview Medical Center. It was conducted in Milwaukee, Wisconsin at the Medical College of Wisconsin, and another large medical center, St. Luke's Medical Center, also at the University of Kentucky and Lexington, Kentucky, and at Emory University in Atlanta, Georgia. And we enroll patients at those sites. What we had proposed to the NIH is what we would look at the sequential organ failure assessment score between 0 and 96 hours, that we would look at plasma C-reactive protein and thrombomodulin, and we were interested in ventilator-free days in patients with respiratory failure, intensive care unit-free days, how quick did patients get out of the ICU, hospital-free days out 2 months from the onset of the study. And then finally, we were very importantly interested in all-cause mortality, basically at 1 month after the onset of the illness. People were included in this study. And again, you can think about COVID pneumonia as well while we're talking about this. Mm-hmm. Patients with severe bacterial and viral sepsis, patients who had ARDS, acute respiratory distress syndrome, and we used an oxygenation criteria to permit patients to come in the trial, which basically is patients weren't enrolled until they had serious acute lung injury and respiratory failure. Patients had to be on a mechanical ventilator with an air tube in place. They had to have chest imaging, which showed bilateral opacities like I showed you at the beginning of this talk.
Right.
They had to have met ARDS criteria, and it had to have been met within 24 hours. Mm. And there could be no evidence of heart failure.
So basically what you're saying here is that these patients were already in the hospital.
They were in intensive care.
They were already into intensive care, and then you waited until they met certain criteria before your intervention. Is that what you're saying?
Exactly.
Okay.
We excluded people who had an allergy to vitamin C. We did have a couple of people. If we were unable to obtain informed consent, if it was greater than 48 hours since meeting the ARDS criteria, and this virtually always occurred if we could not obtain informed consent.
Got it.
Because many people for Virginia Commonwealth University, families live 2 or 3, sometimes more hours away. And we had trouble finding family members to give consent. Pregnant women were excluded. If patients were on home mechanical ventilation, which is relatively common in the US, patients who were not expected to survive, perhaps, for example, with widely metastatic cancer. And then finally, patients who were wards of the state, who were basically prisoners. We could not experiment, quote unquote, on prisoners.
Okay.
So we screened 1,262 patients, and we had a number of exclusion criteria, and we ended up excluding 1,092 patients all the way down to excellently described 170 patients who were randomized. And what I mean by randomized, they either were going to be assigned to get vitamin C or they were assigned to placebo, which was just the ICU standard of care. And the patients who ended up in the vitamin C group also just received standard of care, except they were receiving vitamin C. And after we randomized in the placebo group, which was 83 patients, we found one patient with acute eosinophilic pneumonia, which occurs and looks like ARDS, but it was not bacterially produced ARDS. And in the vitamin C group, we had two patients with severe leukemia who were in respiratory failure because their lungs were hemorrhaging. And so we excluded those two patients, so-called alveolar hemorrhage.
I see.
And so what we ended up with was 83 placebo and 84 patients in vitamin C. And in the vitamin C group, we scheduled patients to receive 50 milligrams per kilogram of body weight infused over 30 minutes every 6 hours for 96 hours. Mm. And we reported this in 2019 in the Journal of the American Medical Association.
Isn't that one of the most prestigious journals in the United States?
JAMA is one of the most popular journals read worldwide. And it has a distinction in being one of the highest read journals on the planet.
Wow.
It took, I will say this, it took an entire year for them to accept this paper. We had to go over, around and around. It's an incredible journal, but we had to do due diligence to get it accepted to JAMA.
That is impressive, because I know especially for simple nutrients, there'll be a lot of scrutiny to ensure that this is correct science, right?
Doc, I will tell you, when they did their first review, I sent the manuscript to them in August of 2018. And it took them 4 months to get back to me with a 30-page document with almost 100 items they wanted addressed. Anyway, it's all history now.
Well, folks, that's all we have for now. Please join us next week as we go over Dr. Fowler's fascinating study. Now, remember, this is novel, and I like one of the things that the criteria the government was asking for. It has to be safe. The intervention has to be safe. It has to be non-toxic. It has to be easily usable. And I think that's perfectly, like I said at the beginning, what we need in Africa and other third world countries are simple solutions that do not require as high-tech equipment, because we don't have access to those equipment. And of course, we don't have access as much to specialists either. So I think this is super important. And I think that our healthcare professionals really should pay attention to this, because COVID-19 is just one of many things that will be affecting us in the years to come. So please stay tuned. Make sure you invite your healthcare providers, your doctors, to watch this. The recordings are on our website, brainandbodyfoundation.org, on the NTA Network's website as well. And of course, you can go onto YouTube as well. So God bless, stay safe, and we will see you again next week.